Hello students, today we will learn pair-t-test. To start this pair-t-test, to learn this test, I will start with a very practical example, which is a very valid example nowadays. We know that coronavirus, it's now spreading over the world and it has a devastating effect on world economy and it has a very devastating effect in human lives also. So everyone is trying to, all over the world, everyone is trying to, every country, they are trying to make a drug or they are trying to invent a drug which can cure this virus, which can cure from this virus. So now, hopefully, we consider that we have already discovered this drug, and many drugs has been discovered, and now we are comparing two drugs which has already been discovered, drug A and drug B. So both drugs are effective and both can cure the coronavirus, but uh, we have to test that which drug is better. So now the research questions, the question arises for to examine this testing. Is there any significant difference between A and B? That is, these two drug has effect differently, has different effect on this virus. Different effect means some drug is one drug is more effective, another drug is less effective, or both drugs are effective but compared to one another, so one drug is more effective than the other. Okay, or which drug is more effective. So there are two different kinds of questions may occur. First question is there any significant difference? That is, both drugs just act in the same way, that is same number of persons or same number of patients can be cured from the after applying the both drugs, or the drug A is more effective or drug B is more effective. Okay, so to answer this question we need to apply t-test. So uh, the basic question on the t-test, the basic thing is the t-test. We will apply this test when there is a comparison issue. The comparison issue of the drug. There is different kind of drugs in on after applying the same attribute, that is to cure the coronavirus, or some kind of diets. Okay, so what type A diet, type 2 diet, or some kind of diet which can be applied to the same persons. Okay, and not to the same persons, that is some persons, and we will study the effect of the drug on the same attribute, that is that attribute may be the weight. Here is the attribute is the number of cured person, or the percentage of cure, the percentage of cureness after applying these drugs. Okay, so uh, after we will later see some practical examples of this pure t-test. So now mathematically, that is after applying drug A and after applying drug B, we will see that these are the data. There is some data has been collected. So after applying A, X data, that is x1, x2, x3, x4 and xn1. N1 means, suppose we're applying this drug A to n1 number of persons or n1 number of patients. Okay, so and the effect has been calculated, or the effect has been measured as x1, x2, x3 and xn1, and that effect it may be calculated as the percentage of cure. There is some person, there is some people, one people is one people is 20% cured, or another people is 30 or 40% cured, like this. Okay, so let us we have collected this data x1, x2, x3 uh, and so on, and x1, that is n1 number of patients are there. We have already collected a sample of n1 persons, and we are applying the drug A on n1 number of persons, and we will collect the data x1, x2, x3, x4. That is first person has the effect of drug on the first person is x1, the effect of drug on the second person is x2, and so on. Similarly, the same condition is applied for B1, but see that the drug A has been applied to N1 number of person and drug B has been applied to N2 number of person. So the number of sample, there is a size of the sample may differ. This is N1 and that's N for B, this is N2. It may not be same. Okay, but the calculation, that is a calculated effect, is y1, y2, y3. That is the person 1 after applying the B drug, the effect is y1. In case of person 2, the after applying B drug, the effect is y2, and so on. Now come to the test statistic. Now we will apply this statistic. There is t equal to x bar plus y bar divided by s square into 1 by n1 plus 1 by n2, and we see x bar and y bar are the mean of x and y. So mean of x and y means, look at this, there is all the summation of all these x1, x2, x3 plus x1 divided by n1. Similarly y1 plus y2 plus y3 and so on divided by n2. This is y bar. So x bar is the mean of all these x values and the y bar is the mean of all these y values. So now and a square is the formula of x square is this. So we say that this statistic, if we apply this formula or if we apply this statistic follows the t distribution with n1 plus n2 minus 2 degrees of freedom. Okay, so just to forget about this t distribution or n1 plus n2 minus 2. What is the degrees of freedom? That all these data, the degrees of freedom and the confidence interval or the the level of significance, the value at 5% level of significance or whatever, that will also already will be given in the question. So now come to real life example of a PIT test. So this example is we are trying to examine two drugs, two diets, that is diet A and diet B, and the effect of we are trying to after applying these two diets on the pigs, we will note the weight, that is after applying this diet, that is pig, the weights of the pigs in kgs has been recorded like this. Okay, so after applying diet A, the reduction or gaining of weights, here it is gain of weights, that is after applying diet A, first pig, the gain of weight of first pig is 25 kgs, the gain of weight of second pig is 32 kgs, and the third pig is 30 kgs, and so on. Similarly, after applying diet B, the pig 1 has gained 44 kilos of weight. Similarly, pig 2 has gained 34 kilos of weight, and so on. Okay, so different, the gaining of weights is the data has been recorded as the gaining of weights of the pigs after applying these two types of diets. Now we will examine, is there any significant difference in between these two diets, that is after applying these two diets, the gaining of weight. Okay, so there is all over gain of the weights, all over gain. It is not that each and every individual, we are not talking about the individual weight. The all over gain of the weight is some better than, that is diet A is better than diet B, or the equal to diet B, or unequal to diet B. That is there any significant difference between diet A and diet B, or diet A and diet B are both same? That is, if we apply diet A or someone is applying diet B, we are gaining the both gaining of, there is same gaining of weights. Okay, so given that now we need to test this, and given that there is t 0.05 at 25 degrees of freedom is 2.06. So t 0.05, it means it is a 5% level of significance. Okay, and so these data will be given to the question. You don't need to think about what is the degrees of freedom, or what is the that is degrees of freedom and level of significance is already given to the question. We just need to think about 2.06, these value we should remember this. Okay, so now let's start the question. First step is setting of hypothesis. So what is the null hypothesis? Null hypothesis, we should what we should test here. We should test here the significant the mean weight after applying diet A, and the mean weight, there is mean gain of weight, the average gain of weight after applying diet A and the average gain of weight after applying diet B are equal or unequal. Okay, so our null hypothesis should be mu x equal to mu y. The mu x is the gain of weight after applying diet A, and mu y is the gain of weight after applying diet B. There is the average gain of weight. Okay, there is no significant difference between these two means. This should be our null hypothesis. So what is our alternative hypothesis? Since there is in this in the problem, we just need to examine whether there is some significant difference between these two diets or not. We are not examining here diet A is better or diet A is better, B is better. Okay, so our alternative hypothesis will be h1 mu x not equal to mu y here. If we say, if in the question we have to examine that diet A is better than diet B, that is diet A is better than diet B, then our alternative hypothesis should be mu x greater than mu y. If we are testing diet B is greater than diet A, then we should say right here mu x less than mu y. So that will be the one-tailed test, but this is a two-tailed test. Okay, now just you need to remember the statistic. Okay, so what is our statistic? This is our statistic formula. So statistic formula is x bar minus y bar divided by a square into 1 by n1 plus 1 by n2. And what is a square? A square is this, x minus x bar 1 by n1. What is n1? N1 means the number of eggs, that is number of diet A. The sample size is 1 2 3 4 5 6 7 8, that is just count the numbers. Similarly n2, what is n2? N2 is count this number which is applicable in diet B. So n1, we have found that n1 is 12 and n2 is 15. Okay, and n1 plus n2 minus 2, this is a simple calculations. Now we should calculate summation of x minus x bar whole square and summation of y minus y bar whole square. How can you get it? Just make this table. These are the x data which is already given in the question. These are the y data which is already given in the question, that is x data can be represented by diet A, and y is the representation of diet B. So just write this data and find out x minus x bar. What is x bar? X bar is the mean of x, that is first find the mean of x. Okay, that is add all this data divided by the number of sample size. So get, and x minus x bar means 25. What is the mean? First we the value of x bar. Okay, the value of x bar has not been calculated, but it will be the value of x bar, you should calculate it, value of x bar, and just the value of x bar, you just subtract the value of x bar from 25, subtract the value of x bar from 32, subtract x bar from 30, and subtract this x bar from each and every number and write here. Okay, similarly this is x minus x bar, the next column it should be x minus x bar whole square. Okay, that is 3 square 9, 4 square 16, 2 square 4, and so on. The same case, similar case should be applicable in y, that is y is 44 here, so y minus y bar, it is, just calculate y bar first. Y bar is the average of y, find out the average of y, and suppose average of y is y bar, so 44 minus y bar, it is 14, 34 minus y bar, it is 4, 22 minus y bar, it is minus 8, and so on. Just now calculate each and every number, and then y minus y bar whole square, that is 40, 14 whole square, 4 whole square, minus 8 whole square is 64, and so on. Okay, now what is the formula? Formula is summation of x minus x bar whole square. So summation of x minus x bar whole square is just now add all these numbers. That is x minus x bar whole square. These are the values. Add all these values, we will get 380. Similarly, y minus y bar whole square, add all these values, we will get 1410. Okay, so just put here the values and find the value of a square. We already know what is the value of n1 and plus n2 minus 2. Okay, so a square value is 71.6 from this table. Now find the value of t. Okay, you already find the value of a square. The value of a square is 71.6. Put here. Already you know what is n1, you know what is n2, x bar the average values of x, y bar the average values of y, average value of y. So put all these values here and we will find t equal to, okay, so x bar is 28 and y bar is 30. Okay, whatever, the value of t is minus 0.609. Okay, so now what is your task? The last task is very easy. Now last task is to check and confirm that whether we should accept the null hypothesis or reject the null hypothesis. Now minus 0. Since it is a two-tailed test, if here it is a not equal to sign, so it is a two-tailed test. In case of two-tailed test, whatever the value of t we will get, we already seen already have seen in the previous z test or simple t test. That is we know that if it is a two-tailed test, we should find out the mod value. Okay, so the value of t is minus 0.609. We should calculate mod of t. So mod of t, obviously it gets a plus, so it is 0.609. so 0.609 is the value of t. Okay, now come to the question. What is given in the question? Given that t 0.05 at 25 degrees of freedom is 2.06. 25 degrees of freedom means, what is degrees of freedom? We in the formula we know that degrees of freedom is n1 plus n2 minus 2. And what is n1? The n1 that is the data of x1. N1 is 12, n2 is 15. So 15 plus 12 minus 2. Okay, so it will be 25. So 25 degrees of freedom. So already the data is given in the question. So at 25 degrees of freedom and 0.05 level of significance, the value is this, it will be given. So you don't need to think about what is the degrees of freedom, what is the what is the level of significance. You don't bother about this. You only bother about what is the value of this. 2.06 is the value and your value is 0.609. Okay, 0.609 is, that is if we should mod t, since it is a two-tailed test. Okay, so not equal to sign is there, h1 is not equal to sign. Look at this. So it is a two-tailed test. In case of two-tailed test, find mod t. Okay, and mod t is 0.609 and we just need to find out is 0.609 is greater than this value 2.06 or less than 2.06. If it is less than 2.06, then we should accept the null hypothesis. Otherwise we should reject the null hypothesis. Okay, so now check it. Very easily we can see that 0.609 is less than 2.06. Okay, so here we should accept the null hypothesis and our conclusion should be there is no significant difference between the mean increase or the average increase in weight due to the diets A and diets B. That is, both the diets are almost equal. If you apply diet A or someone is applying diet B, the increase of weight will be similar. Thank you for listening to my video.